1, 2, 3 test. 1, 2, 3 test. Sweet. Čekaj, imam posebno majicu. Dear listeners, hello and welcome to Road to Dynamic LINQ Part 2.
Yes.
Last time we talked about expression trees because we wanted to create some dynamic query against SQL database using entity framework. So I'm Fosna, you know me. Last time we compared abstract syntax tree that Roslyn uses when compiling C# and expression trees which are available in runtime when you write lambda expressions that are then transformed to this form. Expression trees consist of tree of expressions. Expression can be plus, can be member access, can be a lot of things. Basically, not basically, but everything in C#. We presented two ways to build expression trees. One is using lambdas. The other one is using query selector syntax, which is similar to SQL. So this is number one, and number two was building expression trees using expression tree API. The crazy thing about this was it gets complicated pretty fast, and why would anyone want to deal with such complicated code? Now we are gonna see some demos, but before that, let's see what's the problem, which problem may arise. Okay, if you have an application with a lot of grids, possibly a business application, if you're not using some sort of reflection or expression trees, then you have to implement data access mechanism differently for each table. And then you have to support each column for sorting and filtering, probably. You do. Let me show you how this works in one application that we built some time ago. I'll try to reach it. Okay, here you have one grid, and if you filter it for code, for example, and some name, and then you sort it by price, what's happening on the backend? I mean, backend of the browser. In the network tab, you see that this grid creates an AJAX request that gets sent to server. What's important here that we are requesting 30 rows from the first page where we are sorting ascending by price, and filters are 0, 1 for code and SON for name. If we go to code, see how does this look like in the code. There is a controller on MVP on MVC application that receives these fields and then selects products with brand and group and something else. And then for each field, we have one if that's used for filtering. So code would go here, see that there is some code filter, and would append to this query code contains, and it would append code value, that's on, and so on. And then for sorting, you have property type in string, and then you have to, from this string, conclude which lambda expression you need to build. So this is one way to do it. There's another way. You can create smarter filters here and then throw in some flags that will exclude something and so on. Anyway, this is fragile architecture and it's not really reusable. So let's go to presentation and see how to do it with expression trees, how to do it in more usable way. So I've created a demo. Demo is simpler application, but mimics this example. So you have some strings that are sent to server here in console application that will eventually get compiled to some SQL query. Let's source something in demo. Here is the program. Expression tree show off. Let's see demo number 1. What we did here. There is a simple collection of 3 items. Here are some people. They have a name and age property. And on the first part, we are sorting this collection by name, and we are using custom sort. And that's basically the same strategy we saw in an earlier example. And there's an implementation that works the same, but is using a generic version with expression trees. Same thing here. You can just change parameter and sort by age. Let's dive in the code and see what's the difference. We'll start from the top. I take a look at the person class. That's about it about the person. And now we are sorting this collection. Let's first see the old way. So to show off custom sort, we are sorting crew by name ascending. Okay. This is just gibberish to display it nicely. What we have to do is to guest custom sort selector. If you're sorting by age, we want to create lambda that looks like this. If you're sorting by name, here will be x.name, and so on. This is a simple example for this demo. And then we want to pass this function, this delegate, to this fella that will take this crew collection and sort it based on ascending or descending, passing this delegate that we created here. So how do we get custom selector? Well, you already saw that. This is resolved at compile time, and that's pretty much the problem. Now, just take a look here. This custom sort is bound to person. And when we compare it to the same thing, but done differently, let's show off Let's go from the beginning. So we go to sort demo to sort crew. We saw how does a custom sort look like. Now we will see a generic version with expressions. So we passed the same parameters. And the core implementation, we want to build this expression dynamically, and we'll then parse it not parse it, but compile it to delegate and pass it to the same function as we did before. So to get the sort selector, notice that this is bound to T. It's not bound to person, which means it can be reused for other sort of collection. Okay, now let's build this fella. To build this, we need expression parameter type of X, and then to build property accessor for age, we'll use property expression builder with parameter that we just built on the left side, because it has to be the same, right? And we're passing in our sort property name. So there is no if else if you want to, and you don't have to keep this in sync, right? So when you use this syntax, first you build this X, then you build this property gather, and then you have to cast it to object. This is something to help the compiler. And then you create a lambda. That means to this two things, you add this arrow, basically. And the last thing you have to do, because you're working on collections and you're working with delegates, you have to compile it. If you were to execute this against SQL Server, then you would return expression. Because as we last time saw, lambdas are tricky because they can be treated as delegates or expression trees. In LINQ to SQL, we treat them like expression trees. So in LINQ to SQL, you would pass this to where or sort function. But in LINQ to objects, you have to create a function. That means delegate. Okay, now we created something like that. We go back and pass this sort selector function to the sort, and it does its magic. So we saw how that works. Are there any questions? Did anyone get anything? I guess not. Okay. Let's proceed. So the same thing you have to do with where. I mean with filtering. There is an old way and a new way. But where expressions can be more complicated because you have to compare a value that you accessed from the object to something. Let's see, how do we do that? Check out the demo. Okay, so the same. Now we are filtering the same connections by age. We are asking to find a person with age 43 with custom filtering and this generic filtering. We're doing same thing for name. Notice this comparison is only by equals. So there is no contains because it's not supported in this implementation. If you need to support a full-blown grid, you would probably need to implement it. So this is just an idea. Take a program. Filter demo 2. So we are filtering collection by age or name. Custom filter. So what's the difference between filtering by age or by name? You have to pass different lambda to where function. That means if you're filtering by age, you have, where age is 3, you have to pass lambda like this. But if you're filtering by name, where name is J, then you have to create lambda that looks like X name equals J, right? And then when you have this part, so that's delegate, you just pass it to where function and it gets filtered, right? The trick is how to build this part. Okay, by hand, and it works, and it's easy to debug, and it's also easy to extend, to understand how to extend it, but you'll have some work to do. If we see more generic version, show filter. So this is hard of the process. Get filter constraint. Notice that this is parameter of t, so it's reusable. We're passing the same parameters. We're expecting the same thing out. So this is how you build the x. Expression parameter. This is how you get this feller. Get property value. You're passing property name here. Only God knows if this will actually get compiled and be found on object, because you can pass in monkeys here or cats. And then you have to pass filter value, right? This is this filler. And then you build the body of lambda, so you have to compare it. This only supports equal. If you want to support contains for string, you will have to expand this idea. And then bring it all to lambda, since expressions need to be compiled to delegates. Call compile, and you have to cast it, of course. And now you have a function that looks like this. You just have to pass it to where. So that's how you can build support for it. Now, there is a good project that's mentioned in references in the presentation that takes a string and does, for example, filtering, but supports also contains, greater than, less, stuff like that. That might be nice to look at. So this is about filtering and sorting, and we covered this first problem. Now we're making up problems just to see if you're smart enough to wrap it up. And this is when you don't have C#6 for some reason. You can still get property names using type safely version. For example, you can call name caller, get property name from person name, and this would return string name. If this property gets refactored to first name or surname or something else, then this function will return something different. You can do this with reflection, right? But this is somewhat faster. You're using the same thing when you're building views using HTML helpers in MEC. So this is known. Would you like to see the implementation? Yes. Okay, great. So here we won't build expression trees because they're built at compile time. We'll only parse them to get one small string. And this is demo 3. It's all about parsing expression trees. The name of age property is age. That's not something really smart, but Please refactor. Offer refactoring. Control dot. Yes, you do that. If you run it again, QHH. This is the whole point now how it works. That might be usable sometimes. Useful. I'll rename it back. Program. Let's see, demo 3, setting, show of getting property name. Okay, how do we call it? There's a static class that has one static method that accepts some type and lambda to access its property. So we expect lambda expression here. We know that lambda expression has body and has its parameters. So we see that this body should be unary expression. And this unary expression has only one operand. That should be member access expression. And when you take this member access expression, it should have member name. So let's just debug it to see what debugger thinks of it. Focus. Okay. Come to pop. Okay, member selector has value that's easily readable, but then you have to look in body, and body is of you see it has convert. That means it's casting something, and when you cast something, you expect to have operand, and operand should be, for our example, a member access expression, and then you can look for name, and here is age, and here is how you extract age string from expression. Of course, this implementation covers only one dot, so there cannot be, for example, person.name.length. You have to think of a way how to implement it, but that's the idea. That's it. And there's last demo. I think we are all tired of null reference exceptions. That's why in C#6 we got else operators. Do you all know what else operator stands for? Okay, great. And then there's this default operator. What we would like prior to C# is to write something like x goes to x.child.name, and if this child does not exist, you would not throw exception, but you would, for example, return an empty string or some other default value. I will go fast through this example because it's pretty verbose. I'll just show what's the idea. First, we'll run the demo. It's the last demo today, sorry. Okay, so first time when we tried to access Phil's child name, we got an exception because there was no child. And then we tried to do it safely, and because there was null for the child, we returned default value. That was when we used these expressions. So we took one expression, we extended it, we have compiled it, and run it against field object. And then when his child was born, when we asked Phil to get his child name again, there was child, and then it actually returned child name. Let's go to program. Okay, so Phil is a guy who doesn't have a child. I mean, person class has a child, which is type person. Pretty slick. If you write this, you'll get a null reference exception. So that's clear, right? But if you want to do something a bit neater, show child name safely, you might use this extension method that takes expression, not a delegate. So it takes expression. And if there's null somewhere in between, it will return default value. All right. So what it does? First, it parses expression tree, and it finds parts of it. For example, in this case, it would first create expression x, then it would create expression x.child, and it would create expression x.child.name. Then when we have those three expressions, for each, we would create another expression that checks if x is different than null, if x child is different than null, and x name is different than null. So we have three separate expressions. Now we have to build another expression that wraps them with AND. That means we'll create if true and x is different than null, and x child is different than null, and x child name is different than null, then do something. Okay, so this is our test. So if all that is different than null, then we can use this expression to extract the name. Otherwise, we would return default value. And now we have to create another expression that's just if. So how do we do that in code? We won't go through this. We'll just try to see what compiler does, what the debugger sees at some point. Let me see what window. Or locals. Even better. Oh, there's a selector. Name color. And when we get to the next point, we have some selector parts. So this is what I told you. You have to get xchild and xchild name. And then we'll created some null check parts. This means x is different than null, xchild is different than null, right? And then we have to combine them in one AND expression. Here we have created x is different than null and xchild is different than null, and that here is true because this is AND operator, and this does not matter really. So if this is okay, get me child name, otherwise get me default value. And now we have the expression, you put it into lambda, and when it's in lambda, you can compile it to delegates. That's it. Now you get some value here. For property value, you'll have not available because child is null, right? That's it for the demos. And that's almost it from the presentation. You can find code on GitHub if you want to injure your head or brain. There are some other smarter ideas. With expression trees, you could create, for example, smarter update clause in entity framework or some extensions. For example, let's update zip code for all persons that lived in I don't know, Samobor city. Now you cannot do it. You have to first fetch entities from the database, and then you change their values, and then they get updated. I show you how to do. Oh, you can use this name caller to create type safe property changed. So when you have a lot of property changes, uh, not attributes, but methods, you have to pass property names there. If you refactor something, everything's break. A nice thing is to do, when you have a collection and you call distinct on it, you never know what's the key is the distinction. I mean, you do, it calls equals method. But you can create a distinct overload that sets something like x goes to x.name, and then you will get distinct names. I mean, objects that are distinct by name. You can just change it and get object distinct by age. You don't have to create the whole equality compare. And I don't want to even go into these ideas. Those are really great ideas. If you want to look for them, follow resources and take a look at dynamic LINQ examples, which are really usable for the example and the problem we shown at the beginning of the presentation. Thank you. Are there any questions?
What happens in the first two demos if you pass in some string and the class doesn't have that property? Will it break or will it just ignore it?
I guess it will break during compilation. When you create expression, that's fine, because
you pass in string during runtime.
That's right. There are safety concerns that needs to be addressed, because, for example, somebody can pass a property that exists and that checks something in a database that you didn't want user to see, some prices, some discount prices. And it only takes for user to fake Ajax request, change the property name, and it can get called on the server. So this is only the beginning. You see here, you need to update it to support different comparison filtering operations, greater than, less than, contains, does not contain, stuff like that. There are some other holes, which is great. This is just the beginning. I didn't want it to be overwhelming. Is there something else? Maybe we have someone on the chat. I mean, that's a stretch, but still. Let's see, chat. Got it. Not much. I guess this is a bye-bye then.